Okay, let's look at number 7 here. Identify the amplitude and period of g of x equals negative sine of x minus 4. And describe the graph as a transformation of our parent function. So I went ahead and graphed our parent function here. It's got an amplitude of 1. And notice I drew it on a different scale than the last one we were looking at because we're going to need a little more room to look at this one. Okay, so again, but still it goes up to 1, back down to negative 1, completes a complete cycle or period over the 2 pi of distance or time. Okay, and let's now look at g of x. Well, what are the transformations? Well, what's that negative out front? Well, that's an x-axis reflection. And then the minus 4 is not in with x, so it's vertical. It's a vertical shift down 4. And we want to account for that first, the vertical shift down 4. Okay, and remember, if we're going to do that, the first thing we want to then come in here and do is dot in this line. It's called our midline. And that's at y equal to negative 4. Okay, so we accounted for that vertical shift down 4 first, and then hopefully that x-axis reflection will show up once we get to the rest of it. Okay, so again, let's do amplitude. The absolute value of negative 1 is 1, so our amplitude is still 1. How about our period? Well, that's 2 pi over the absolute value of b. In this case, what's in front of the x here? Nothing, just a 1. So our period is still 2 pi. All right, so then what did we do? Well, we took 2 pi, we divided it in 4 parts. And I add that pi halves to my starting point. In this case, my starting point still, instead of being at 0, 0, is at 0, negative 4 right here, right? But that's still 0 on x. And it's still going to end at 2 pi. So essentially all of my locations are the same. So when I went through that process of adding pi halves to 0, I should get pi halves. And then pi halves plus pi halves is pi. And then pi plus pi halves is 3 pi halves, and so on up to 2 pi. So all of our intermediate locations are the same, but let's find actually the y values, which will be different. Okay, so let me erase a little. And again, this is our midline, y equal to negative 4. I'll leave it there. Amplitude of 1, period of 2 pi. Then what do? Well, we want to make a table. Well, 0, pi halves, pi, 3 pi halves, and 2 pi. And we want to evaluate. So let's evaluate. G of 0, negative sine of 0, minus 4. Well, what's the sine of 0? Well, at 0, sine corresponds to y on the unit circle, and at 0, y would be 0. So negative 0 is just 0. 0 minus 4 is minus 4. G of pi halves. And we already knew that. We had that labeled on there. Negative sine of pi halves minus 4. Well, what's the sine of pi halves? Well, pi halves is 90 on the unit circle, so I know sine corresponds to y, and y is 1 at that location. So that's 1 times negative 1, negative 1, minus 4, minus 5. And I'd go through and I'd evaluate my other locations. And it should look something like Okay, and then let's go ahead and graph them. At pi halves, I'm at negative 5. And again, there's negative 5. At pi, I'm at negative 4. At 3 pi halves, I'm at negative 3. And at 2 pi, I'm at negative 4. And then I want to go ahead and draw my shape. Because you need to make sure and label these intermediate locations as you go. Okay, so that x-axis reflection is really a reflection in the midline. So it's a midline reflection. Is a better way to think about it, because essentially we flipped it over the midline, didn't we? Instead of it opening up, it opens how? Well, it opens down. Okay, and remember, since sine starts at 0, 0, it'll either open up or down. And we'll look at cosine in a minute. That's a little different. Okay, so the negative out front there makes it open downward instead of upward. And then it's shifted 4 down. So it still has the same period length as our, say, original parent function. And sorry, on this graph, these should be here. Let me be a little better with my graph there. Okay. Goes through the locations and it hits at that point. It shouldn't go below it, right? Okay. Okay, so instead of it opening upwards, as it headed towards pi halves, it opens downwards. And then everything's essentially flipped over that midline. And it's shifted down 4 as well. Okay, so it's a vertical shift down 4 and an x-axis reflection, but we'll really think of it as a midline reflection. Okay, thank you.